All right. Yeah. Thanks, everyone. I guess I can start. So the talk is SBT 2.0. Go big. So the four character means sort of the great unfolding of the great plan, essentially. Like apparently it means different things in different like a context, but basically, way I interpreted it is that if you decide to make, big plans, the act should kind of like follow accordingly, essentially, in its size. I'm Eugene Yokota. So SPT is now probably like 17 years old. And I've been maintainer since it was sort of like 7 years old, I think. So the last like 10 or 11 years, I've been the third maintainer. Yeah, and yeah, I work for Netflix, and at work I actually maintain Bazel monorepo and work on the configuration system for the machine learning. So this is sort of like more to do with non-work project stuff. So yeah, let's talk about SVT. It's what's my favorite build tool. So what does SVT stand for? Yeah, so in the past, like we've sort of like waffled around this and says, SVT doesn't stand for anything, but for truly, I think it does stand for simple build tool, and hopefully today I can convince you that at least I'm trying really hard to get it towards an idea of simplicity, and yeah, like we can come talk to me if you disagree. So instead of kind of like designing by kind of like committee, right? I thought like it will be interesting for SBT to sort of like have like a very strong vision of like one person and some sort of vision of what build tool should be. And I think my goal of SBT 2.0 is to literally make it the best ultimate build tool ever. And there's like, sort of like a 5 points that I'm going to cover today, and in this order. So first is about basically like simplicity, or just simplifying build, SBT DSL. Of course, using like the Scala 3 construct will be great. A lot of the portion of this talk will be about caching, my favorite topic, and I guess a lot of people's favorite topic as well in this conference. And want to talk about a little bit about SBT server as well as the continuity and stuff. Cool. All right, let's dive in. Oh, before that, actually. So some of these slides actually feature these buildings, and it's like actually by a Swiss-French architect, Le Corbusier. And this is actually from Chandigarh. I raise your hand if you've been to Chandigarh before. Maybe I'm the only person. Yeah, okay, cool. Shout out to Chandigarh. So he created a bunch of like buildings, government office building. After the partition, the Punjabi government wanted to create like a new capital. So one of his kind of like the model is that the house should be a machine for the like a human or the living, right? Meaning that we can strip away some of these traditions and like ornaments and actually really focus on the functionality for you, who's gonna live in the house. And some of these buildings, and hopefully the concept kind of reflects through these. Yeah, so simplicity, great first topic. We can think of simplicity in a bunch of different ways, but I think one way to think about simplicity is getting the basics right? Like it doesn't matter if it's like just like plain looking, you can just call that simple. It has to actually know what you're gonna do and focus on the basic usages. And the basic usage and the thing should be flexible enough to basically get rid of some of the ornamental parts. So, I hate to use this analogy, but think of it as like a simple knife, like a hunting knife, versus Swiss Army knife that has a bunch of different tools, right? So the aim of the simplicity is like think about that particular usage, like for phishing or whatever, and then focus on that. So what does that mean for SBT? So for SBT, our like basics is like compiling, testing, publishing, right? And we might now take it for granted, but if you go back before SBT existed, right? We really focused on these things because it's SBT that introduced incremental compilation. We basically put API in front of the Scala compiler. It's SBT that defined the JVM sort of convention for the test interfaces so that we kind of take it for granted you can use any testing library. It's basically we're one of the only tool that you can sort of do that without even changing SBT itself. You can use like MUnit, Scala test, JUnit, whatever you want. Why can we do that? Because we have the test interface. And you can use any Scala libraries or Scala versions because there's a compiler interface to do it. Similarly, for publishing, we support cross-building, of course, but most recently, there was this whole like Sonatype changing its interface. We quickly jumped in and fixed that kind of stuff. The other aspect of sort of like more like a minimalism is that we have very, very few concepts, and we basically try to solve all the problems using these few concepts, and namely that's like tasks, settings, and subprojects, and that's it. So simple things should be easy, right? So for things like setting the compiler version will be like the, Scala versions, colon equals, and you can do that. And for adding like the library dependencies, these are basically the basic usages that we kind of expect so like end build users to be able to do. And sort of like our general DSL strategy is that at the very core of SBT, I think SBT has been kind of an interesting project. It's been like there for a really long time. And for its kind of like diverse use cases, the core has been really, really stable. Like we never really have to touch it unless like we decided to go into like a Scala 3 or something, right? But like apart from those kind of stuff, the core is fairly stable because it almost doesn't know anything about the build. It's basically like you take a task and you kind of launch it out. A lot of the complexity sort of in the middle part where essentially we implement a program on its own. So what's interesting about SBT is that it's probably the only build tool out there. You only need like a blank build file that says build.sbt. And SBT2, that will default to using Scala 3, right? You don't even have to write anything. So one way of thinking about this is that we basically make 3 different columns. All the way towards the left is the build user. So the build user will be essentially appending like a language extension essentially, whereas in the middle part was like the library authors. So that's kind of like our DSL strategy is that people who want to kind of like extend the usage of the build itself, they can do so freely without asking SBT itself using plugins. Whereas the end users, they'll be kind of like using these like relatively simple settings. And the core basically focuses on the core. So what does task do, right? Like setting is basically to influence this whole graph of like kind of settings or tokens or whatever you want to think about in these like a parsing graph. Basically what task is doing, and there's like a purpose of the SBT's the DSL is essentially kind of like algebraic effects using a direct style. And we have been doing that almost like without even knowing since like 2013 or something. Now it's like, everything is kind of like super whatever mainstream to talk about effects and like effect handlers and stuff. But essentially the purpose of task is to do effects. And why do we do that? It's mostly for what we today call fearless concurrency, right? So when we say task, like the task1.value, task2.value, these are essentially calling for the effects And without using for comprehension, task 1 and task 2 will be like running in concurrency, similar to like using future, basically. So yeah, essentially we use the kind of like an AST graph to deduce the task graph, and therefore we provide essentially the structural concurrency. So there's like pitfalls, obviously, to some of these, like the SBT stuff. So one of the things is that if you write like Scala versions, and so we call it like a bare settings to write it directly into the file and mix that with the kind of like a multi-module build, you might expect the top value to affect the others, but currently in SBT1, that only affects the root. So to work around that, we sometimes kind of recommend people to use this build. And it's actually kind of like it works for Scala versions, but you kind of have to know the internal details of how different like settings are used, because if it actually was used at the project settings, this technique wouldn't work. And to make it even worse, it doesn't do the dynamic dispatch. So dynamic dispatch is kind of like more kind of like a PL-ish way of saying it. But like in typical like object-oriented programming language, like you expect that the, like a draw dot method or whatever method to happen at the point of like a circle class, not the shape class, right? If the circle inherited. So in this case, you kind of expect like the name.value to know about the fact that it took place inside of some subproject. But in SBT1, basically name.value would be evaluated at the root project, in which case it will actually capture the name of the directory that it's in. So SBT2, like, this is one of the reasons like, I think I can make this simpler, is we can basically inject that first top line, the bare settings, into every subproject, and that basically solves kind of like a two problem at the same time. Number one, you write Scala version there, then it will affect all the subprojects. And number two, if you decide to do some more like complicated like expressions or just like, use some stuff from the subproject, it will dynamically dispatch essentially. So another sort of like kind of like opportunity to kind of simplify the concept is the cross-building story. And cross-building, so if you're not super familiar with what SBT is, because like since we have a lot of people, the Scala and the SBT is capable of being able to take the same source code and then cross-build it across multiple versions of Scala. And in the earlier days, that was really necessary because like every half a year or so, Scala team would release a patch version of 2.8.1 and 2.8.2, and that will break the binary compatibility. So basically, people had to constantly publish new versions. So one way to work around it was just, okay, just take the same source code, just publish it again on Maven Central. Then came JS and native. So there's like sort of like a two-dimensional matrix. And project matrix, instead of using states, which what plus command is, you change the state of the build, or just basically create a synthetic subproject. So not only you can do cross Scala and cross-platform, you can do that in parallel. So with project matrix, you can run in parallel. So it's like now, it was a plugin, it's in-sourced, and it's been influenced by two existing plugins that existed. So these guys here. But, wait, sort of. If what happens with the project matrix now is that one subproject now expands into like 6 or so, like whatever the matrix, right? So if you decided to do JS native on top of JVM and you want to do like a 2 versions or something, now you have 6 subproject. So that's kind of like inconvenient when you're actually trying to code. So one thing basically like kind of like borrowed or like taken from the Bazel world is this idea of the Bazel query. So Bazel query basically is a way to specify what action you want to take based on the sort of like a folder names or sub-project names or whatever. So here, ... means just take everything. Why didn't I use star, you might ask, right? Because if you use star on bash, that will match with a folder name, and typically you would have a folder named test in there. So it will basically match to some like random folder that has the word test in it if you're trying to run test. So basically ... is kind of like a Bazel convention. I know it's weird, but like you'll get used to it. But if you say like core ... that basically means like it takes the sub-project that starts with the word core, and then you can specify, I just want us to do the Scala 3 or whatnot. So yeah, that's kind of like the idea. All right, so I want to kind of quickly go over some of the Scala 3 construct. So one of the motivations for SBT2 was that I knew it uses like, SBT has a lot of macros, and if I were to sort of like sunset into some other project or whatnot, I thought like my responsible thing to do for longevity of SBT is at least like comprehend the macros that we have in Scala 2 world and then migrate it to Scala 3. So that's basically the project I've been doing for the last, I don't know, like several years. And the rest is basically like whatever. But so that's one of the things. And I think the cool thing about the inline is some of the macros that's super complex. Now you can just kind of write it in like a simple inlines. Yeah, like the opaque type, it's pretty cool. Like instead of using like string, you can kind of like make a special case string for digest and all that kind of stuff. And there was a concept called like A-list. I think it stands, my guess, is for like arity, something list. So in SBT, there's a lot of these like tuples that we use internally, but after 22 or whatever size, we can't make any more stuff. And then on top of the tuple, we also need to say that I want a tuple that has specific property inside. Namely, like I want stuff that has settings, basically. All of that basically goes away with Scala 3 internal. So it's all internal code, but it's pretty cool that basically tuple, you can pretend you have an H list. So it's pretty cool feature. You want to check it out. Tuple map is what basically K-list is in the Scala 2 world or SBT1 world. That expresses that the member of this tuple would satisfy specific kind of like higher kinded or the type constructors, basically. Yeah, so this is like some of the examples I have. This like wall of text that you can't read. This is like what SBT1 would have done. And SBT2, we put these like, so this is the dot value, by the way. So if you see there's like a snowman Unicode there, I think it's Mark Hara or Josh, either of them chose a snowman. That basically means like human would never use that stuff, so we just use it. And that's how you denote like a dot value. So if you say like name dot value, it's actually wrapping in the snowman. Yeah. Another sort of like a cool thing is so this is actually exists in SBT 1.4, but yeah, so I just wanted to talk about this. It was pretty cool. So the applicative does the parallel, and monadic composition does the sort of like a sequential, right? But sometimes you actually want to do somewhere in the middle, and that's what the selective is. And that's super useful because SBT provides this thing called inspect command, which lets you inspect what task depends on what. I mean, sometimes you want to see like selective stuff, where it's like skipping is a great example, where if you skip it, then you take the other branch. So this, if you write top-level if expression in SBT2, it actually compiles into a selective functor so that it wouldn't execute or depend on the other else side. All right, so let's talk about caching. So caching, I think, is like, one of the two hardest problems in computer science. One is caching, the other is making money with open source. So build time, I don't really have like a paper about this, but this hopefully is super intuitive to everyone, is that the build and test time is important, and it grows quadratically. What does that mean, quadratic, right? Like n square. Because suppose you have like 10 people team, right? Monday, you come to work. How many people's code are you gonna have to compile? Hopefully, like, if you have an incremental compiler, you don't have to do yours, but you still have to do 9 other people's if you do git pull, right? And then you decide to like hire 10 more people. Now you're compiling not only your code, but 19 people's code, right? So you start to like get a coffee break, and then you ask the other 19 other guys saying, hey, what are you doing? It's like, yeah, they're compiling. So essentially, the more people you add, this problem compounds into this like a build time explosion. This is a fairly well-studied problem to the point that we actually now have solutions for this, which is caching, right? That's what Google does with Bazel. Meta uses Buck, blah, blah, blah. So the idea is basically let the CI or other people's laptop, they run the test, and you just cache the result. So the idea is to flatten the curve. So it's actually kind of meaningless to talk about like 10x or whatever x. X actually doesn't matter. The bigger the code base, x will be larger. X just like, it's just how flat it is that what matters, basically. So if you can't get your CI time to be O of sort of like, not constant, but at least like somewhat linear, then like it's not doing the job. So but that's basically is the goal. Otherwise it can like explode, like I said, right? So the main feature of SBT is that basically if you were gonna do this caching thing, right? Let's make it compatible with Bazel's caching system, which is pretty cool, I think. So you don't have to do this. This is not like obligatory. Like your disk would act as cache, that's fine. But if you're using Scala at work and people are like, we want to like do these hardcore code generation that takes really, really long time, or we want to like double the size of the adoption within your large company or your own company, then there's basically like folks out there, and some of them probably sitting in this room, who basically work on these systems like InchFlow, Build Buddies, and Gradle's DevVelocity. So DevVelocity, by the way, is like it's created by Gradle, but it works with SBT1, and hopefully it will work with SBT2 as well. Native Link is a Rust implementation of the build caching system, and that's open source too. So if you want to run any of these, many of them actually have open source, but like I kind of recommend just like let the pro handle some of the hosting problem because it's sometimes not worth it. One thing that you take away from this talk is that in SBT2, test results will be cached on CI, which is kind of like controversial potentially, but think about this. If you want to avoid the explosion of the thing, it's not just your laptop that matters, it's the CI that matters, right? So you want CIs to be like minutes, hopefully, not like hours, or even like 30 minutes. It's kind of like long. Because like, what are you gonna do for 30 minutes if you're like stuff, because it's not just one commit you're gonna make, you're gonna hopefully do some code review and code generations or whatnot, right? It's gonna be multiple times you're gonna be waiting for CI. So if you can get CI to be minutes or even seconds, then that's going to dramatically change the coding culture, I think. And it does. And this is basically what Bazel does. And the dirty secret, or not dirty, but like secret of Bazel, why is it so fast? It's really, really fast, is it doesn't run test. It doesn't run test because the test result is cached. So SBT has had that functionality called test quick. And it hadn't been turned on, maybe because they thought it's too crazy. But I'm basically flipping it in SBT2 for that to be the default test task. And if you're still kind of paranoid and you want the whole thing, you can always call test full. Cool thing about test quick is that it's also an input task, meaning that it's a task that accepts argument from your shell. So, and the filter, you can pass in basically like a glob expression of the class name. So not only it's going to be incremental, you can put filter on top, so you can basically test only the class you want to test. So kind of like memoization 101. To do caching, you have these inputs, right? Like other tasks are basically inputs. The shape of your task is obviously another input, because if you change like 1 plus 1 and you change it into 2 plus 1, even though there's like some other task dependency, the value that you put in 2 plus 1 plus whatever the result, so you have to take cache of that, right? And there's a concept called Merkle tree where you take the hash of all these inputs, and then you just take hash of that. And you keep just doing it like turtles all the way down, and hash of hash of hash. You can sort of say that there's an identity for that particular task. Has this ever been calculated in the world, ever? And then if it has, then you store the result in JSON. That's basically kind of how it works. But there's like a slight other amendment, which is like a SQL file, but we'll get there. So kind of remember the purpose of these like DSL, right? So there's a concept called effect handler, right? Which is once you have these graph of effects, can we take some action? And I'm not giving DSL some sort of like a crazy effect handler syntax. I'm just going to implement it myself. What I've implemented basically is that by default in SBT2, all tasks will be cached. That's basically the semantics. So not only we have sort of like a fearless concurrency in SBT2, much like Bazel and other kind of build tools, it will automatically try to cache your task. That means sort of like the onus will be on a lot of the plugin authors to make sure that it works, but basically there is now a tool to do so if you want to. And compilation and all these things are now kind of cached, right? So yeah, if you want to see kind of like how it works, there's actually like a command, like the flag that I added called like a macro settings that you can put it into the settings to see what this expands to. But essentially it's kind of like doing whatever I said, like you take the hash and then if it exists, you grab it. And if it doesn't, you actually evaluate the task. Let's talk about a little bit of the problem as well, right? So there's a reason why it's one of the harder problems. So number one, probably obvious one, is that if you want to cache something, you need to be able to serialize that. There's no really kind of like going around it. So in SBT, we use this library that kind of like called the sjson-new. SJSON-new is sort of like a backend independent JSON library that you can use for different like ASDs, but we use specific implementation of the ASD. So we need to be able to have a codec for that. And then there's a project called Contraband that can kind of like auto-generate the stuff for you. But if you have your own data type, we have to basically be able to say, here's how we're going to like save it in the disk, essentially. Caching is also like as hard or like equally hard as the hermeticity. So hermeticity is the lingo or the jargon that Bazel people use a lot. It basically means that if you want to cache something forever across different time, across different machines, right, it needs to be stable against the machines, against the time. How do we express that concept? We kind of do like a thought experiment. What if you created like a container base? You have no idea what year you are in. You wake up in this dystopian container, and you decide to want to build your Scala program. Can you still do it? That means you don't have like timestamp. Your timestamp is actually 2010. Every morning you wake up, and you don't have access to the internet. Or if you do have the internet, you have like frozen version of the internet. So that's basically what hermeticity is. So if you're extending SBT, you now have to sort of like think about this problem. And yeah, like Matan talked about a little bit yesterday about potential risk of capturing like timestamp if you decide to call like zip, for example. There is a way in SBT to hard code all the timestamp in the zip file to 2010. So yeah, it's going to be a lot. So during the sort of like an interim period, there's going to be, you want to say, oh, this is too crazy. Let's just kind of like postpone this. So I've created a bunch of different ways to opt out. At the sort of like a build level, you can opt out of caching for the custom task altogether. One common thing that the plugin like migrators like do is that you say like @transient, and if you put @transient on your key declaration, then you're excluded from that. Or you can say def uncached, and then that particular instance of the task can be opt out. So yeah, there's a bunch of different ways to kind of get out of it. But at least like we can gradually make more and more things cached when you see that show up on your like a performance graph or something. Yeah, so file requires completely different sort of like, treatment. It's not because like file, serialization is hard. It's because English is difficult. When we say file, what is it? Like, what is java.io.file? What is that, right? It's actually just name of the file that happens to also contain potentially the name of the folder that includes like your last name or something. Like, this is kind of crazy, but like that's basically what java.io file is. So when we talk about like a cacheable hermetic build tool, we have to kind of like reset or be kind of like more fine-tuned about when we talk about file. So there's like a different layers we want to think about. Number one is let's start thinking about sort of like a relative path. That's it, just relative path from your build. And there's a type for that now. And that's basically like a virtual file ref. Another is that the actual physical materialized file that has like jars or whatever in it, like as a result of your building, of your source code, that's the virtual file. That's actually kind of inconvenient because if you want to send a list of files back and forth, list of files, you don't want to send the content of the file each time. You want to send a list of files, right? This is like we're build tools, so we need the list of files all the time. So name is not good enough because you want to invalidate the cache because of the whole like the Merkle tree thing. So there is another third one, which is the proof of the file. It's basically you take SHA-256, name size of the file, and then combine it with the name of the file. So you might see the hashed virtual ref a lot, file ref a lot. That's basically the real like a workforce for the file going forward, I think. Another thing related to this is that caching is I/O effect hard or as hard as I/O effects. What does that mean? Similar to what I said about file, when today there's a task that returns, quote unquote, a file, you kind of expect that there is an actual file that's sitting on your target folder, right? But if you do in the remote caching system, you persist that stuff, what's it going to give you? You're going to get like a SHA-256 or whatever, right? So now we have to kind of teach the SBT that not only we want the name of the file, we actually want to save that file somewhere. So if you kind of like wake up in the middle of the desert in a container in this dystopian situation, somehow you're able to download the content from the remote cache, right? So we have now this a new statement that says like declare output, basically. So if your task decides to output something, you say declare output. So you can kind of think of this mentally as essentially like HTTP push or something. So you want to do this like as least frequently as possible. You probably want to like zip things up if you have tons of stuff. There's a support for doing that using virtual directory. So is this worth it? Is this the hardest problem worth it? I think it is. Like I said, the X part doesn't matter, right? The idea is to flatten this out. But just by looking at some of the blog posts, this is just mostly using SBT1's, results. But like my 45-minute build turned into 3 minutes or something like that. And this ratio is not crazy at all. I've seen very similar numbers with Bazel as well. So, with Bazel, you get like few minutes as opposed to like hours and hours and hours because we just don't run tests. So I think it's worth doing this. So that's kind of like my pitch, and it's kind of like well studied as well, I think. So kind of switching gears to sbtn and sbt server. SBT2, it's like actually the script that launches it automatically uses what's called sbtn. What's sbtn? It's basically the native client to talk to SBT. So this is already available in SBT1 world if you say -- client, but there's a growl native client that basically talks to SBT server, kind of similar to SSH, it just basically sends character by character. So up arrow works, down arrow works, and all that stuff. And SBT server has been kind of like this concept that was kind of like proposed for many years ago. Basically, it's this idea that we have play, we have like IDEs, and you have your terminals, and a bunch of people want to access your build, but if you just launched a bunch of SBT sessions, they're basically like a step on each other, so it doesn't work. So the server basically have like a one server running in the background, and so the Scala Center, when he was at Scala Center, Adrian Piqueras contributed the build server, protocol support. So Metals or IntelliJ, when they import it, they can talk to the running servers this way, while like us humans will just like kind of like SSH into the SBT server and then launch it. But combine it with SBTN, what's cool is that you don't really have to have the shell up and open all the time. That's like something that we used to say, oh, make sure you use a shell. But since it's now like as a running in the background, you can just kind of like type sbt compile or sbt test blah, blah, blah from the bash script, and it'll basically boot up. So here's kind of like, that's kind of like one of the big motivation as well. So I use kind of like a Pecco as an example because they have like 40 something sub-project and like equivalent number of the sort of like a local projects. So if you just do cold start, it takes like 90 seconds or something, and then like, just to kind of get the build going, just like exit. If you do it second time, the first time what it does is actually compiling the local ad hoc plugins. So that takes really long time because you have to JIT the Scala 3 compilers, blah, blah, blah. So that's taking like over a minute. But the second time onwards, now at least those stuff is cached. And the Scala Center, again, contributed a bunch of the kind of like a performance improvement fix. So now even for like 40 sub-project, it kind of loads up in like 20 seconds. But if you want a 0 second, if you use the SBTN, the loading is already done somewhere else. So that's that, right? And I actually kind of like want to start pushing more and more stuff into SBTN. So SBT2 does this thing called client-side run. What does that mean? So when you type run command, like currently in SBT, that kind of blocks the SBT session the whole time. Well, it's almost kind of like waste of the session because it's just a program, and during that time, no one can talk to the stuff, right? So basically, client-side run means that SBTN is able to launch a JVM, and that runs your stuff, and that gives you like an isolation. So yeah, why work on SBT, at all, right? So there's like a bunch of other ideas and build tools and all that stuff. But I think like what I'm interested in and a bunch of people are interested in is let's take what's already there and then try to like improve it essentially to the point that we can improve as much as possible. And that kind of allows us to basically lift everyone up at the same time. And I think that strategy is sort of working for us for now. So there's been surveys. Year after year, we basically get like, depending on like how many Maven hardcore users there is and respondents, there could be like 80% to 90% of the market share of the build tools. And it also means that when there's external shaking that happens, like Bentray decides to sunset something or Sonatype decides to sunset something, or you want to work on JS problem, community kind of comes together to SBT and then implement common solutions. So we sort of act as the hub station, or like or Scala Center patches vulnerability and something. So yeah, so I think that's kind of like reason why I think we should keep working on SBT. And if you're interested in getting involved, there's tons of different ways. Oh, I didn't even talk about the documentation. So I kind of like Cargo's documentation. So I use their like a Rust's tool to kind of like write the documentation in this style, where it kind of like reads more like a manual. So each update command and compile command is sort of like reorganized and rewritten like an individual, essentially, command. So that's the kind of stuff you can contribute if you like to, or just check my grammar or something. Other stuff you can do as a contribution is basically like help other people. Like, you know, I'm just one person, but if you already are very familiar with SBT, help other people in your own company, or, you know, on like the Discord channel or something. And we're always welcome to your feedback and bug reports. So in summary, this is kind of like my ultimate vision. And hopefully that means that the continuity, meaning that this is not anything if we can't migrate together, right? So if you just want to like go fast, go by yourself. But if you want to go far, we want to do this together. So that's kind of like my vision of the SBT2. And I want to thank all the contributors and the previous maintainers and what I call like a plugin park rangers. So yeah. Any questions? I'm not sure if you have too much time for questions, but yeah.
You can take one.
Yeah.
Yeah, the whole story around repeatable builds and timestamps that are stuck in 2010 and so on looks very Nix. Is that conceptually the same thing?
Yeah, the 2010 is the same date that Bazel uses, and maybe like other people have done it. And one of the big reason is because WinZip command, it uses 1970 or 80 as the epoch date, not the Unix, and it basically blows up in all sorts of crazy ways. So yeah, anyway, but 2010 is a number Google decided, yes. But yeah, I'll be happy to answer any of your questions, but yeah.
We have to like
Yeah.
listen.
No, I mean, off the, yeah.